What is a matrix? The traditional notion of a matrix is a two-dimensional array with numbers in it, like this. This has two rows. The first row is 1, 2, 3, and the second row is 10, 20, 30. It also has columns. So the first column is 110, second column is 220, third column is 330. We call this a 2 by 3 matrix. For matrix A, the ij element of A refers to the element in row I, column j. And it's usually written A subscript ij. We'll sometimes use the more Pythonic notation A brackets ij. And here's an obvious representation for a matrix. We can represent this matrix by a list of lists. Each element of the top level list is a list consisting of the elements of a row. So the first list is 1, 2, 3, the first row. The second list is 10, 20, 30. You could similarly represent this by a list of column lists, where there's one element of the top level list for each of the columns of the matrix. One simple rule for matrices is as a way of packing together a bunch of rows or a bunch of columns. We define two vector spaces for each matrix M. One is the column space, which is the span of the columns of that matrix M. The other is, and it's written col M. The other is the row space of M, which is just the span of the rows of M, and that's written row of M. So for example, the column space of this matrix is the span of its columns. The first column is 110, second column is 220, third column is 330. Now in this case, the span is just equal to the span of the first column, 110, since the other two are scalar multiples of that. But similarly, the row space of this matrix is the span of the two vectors 1, 2, 3, and 10, 20, 30. And again, this is also equal to the span of just the first vector, 1, 2, 3, since the second one is a scalar multiple of that. Transpose swaps rows and columns. So if you start with this matrix, where the row labels are A and B, and the column labels are at, sharp, and question mark, you apply transpose, you get this matrix. So for example, the entry in row A and column sharp of the original matrix is the entry in column A and row sharp of the transposed matrix. Pretty soon we'll explore the operations on matrices, but first let's note that a matrix can be interpreted as a vector. After all, an R by S matrix is just a function from the Cartesian coordinate R cross S to the field F. So it can be interpreted as an R cross S vector.